Okay, so you're going to do the lab with me, and I'm excited that you're here with me. Let's take this nice and slow. So, I'm going to open up my interactive by clicking on the interactive here. Boop. And it opens up. And let's go to friction, because today we're testing friction. And here we are. All right, let's go back to our assignment now. Okay, first thing I have to do is set it up, make sure these three boxes are checked. 1, 2, 3. All right, let's look at the first question. In this image below, the image below shows applied force pushing to the right. So here's applied force here. What force is pushing against the applied force? So if this is pushing this way, this red arrow means that's pushing. So friction force. Yeah, that makes sense, right? If you push that way, the force pushing against you is friction. So let's click on that. It makes sense, doesn't it? It's kind of like if you try to push somebody who's sitting on the carpet, the friction between the carpet and that person is going to push against you. Let's do the next one. All right, so we have apply a force of 100 newtons to a 50 kilogram box. To do this, click the double fast forward button on the bottom of your screen twice. And the question is, did the box move? So we're going to click this button twice, and we're going to leave this set up. So let's go over to our simulator. You ready? So I'm going to click this box twice. Ready? 1, 2. No, the box does not appear to be moving, does it? And you know the sum of all forces, that equals 0. That means it's a balanced force. And remember, when forces are balanced, there's no motion. It needs to be an unbalanced force to move. We learned that, I think, in 3rd grade when we did our tug of war and other activities related to force and motion. All right, let's go back and answer that question. So it did not move. No, the box did not move. All right, now we're going to set the friction to lots. We're going to set the friction to lots. So let's reset. Set the friction to lots. And then we're going to apply all of these different forces, and we're just going to keep going up until we see when it moves. So here we go. You ready? I'm going to put the sum of forces up here also. I think when the sum of forces changes, that's when we know it'll be motion, because it won't be balanced. Ready? 50. Nope, still not moving, still balanced. 100. Still balanced. 150. 200. 250. 300. Oh, all right. So at 300 newtons, it moved. All right, I'm going to reset that. Let's go back and answer that. So it moved at 300 newtons. Okay. Now, oh look, now none. So let's see, let's go back and do it over. Now we're going to slide it over to none, ice. So what, anybody have a prediction on this one? Well, trying to slide something on ice is not so hard, is it? Well, let's try it. Let's go. Let's put our sum of forces up and begin. Oh, it's already moving at 50 newtons. It's already moving. All right. So we can go back and 50. Now let's talk about this statement. This is the last thing. Complete the following statement. If I decrease the amount of friction, the amount of force, the amount of applied force required to move the box is increased, decreased, or remains the same. Let's look at our interactive again. Now, think about it this way. If I start up here at lots, it took 300 newtons to move it, right? But then I went down here and I reduced it. So I decreased the friction, and it only took 50 newtons to move it. Isn't that interesting? Look at this. I can do it this way while it's moving. Look. So when I add lots, it stops the box, but when I slide it down, the box moves. So the answer to that question would be, as I decrease the friction, I also decrease the amount of applied force required. That's the answer. So, as friction increases, force required to move something increases. And as friction decreases, force required to move something decreases. Makes sense, actually, doesn't it? All right, great job. Thanks for joining me for this. Bye.